So the first, the simplest one type of phase transformation is solidification. It's very important. In the beginning, we talk about it. Solidification going from liquid to solid. It happens in polymer. It happens in ceramics. It happens most often for metals. Okay, and quite often when you cast a metal parts, for example, if you have an engine block, the big engine block, cast iron or cast aluminum quite often, and that will cast the copper part. Okay, and for semiconductors, as I showed these images in the beginning, what this guy's holding his hand on? It's actually a piece of so-called polycrystalline silicon. And how do you get this piece of polycrystalline silicon? You cast the melted silicon metal, liquid metal, into a mold, and when it's solidified, it gets into this large block. And when you dice it up, when you use diamond saw to cut it up into this thin slice, you get this patchy pattern. What does the different shades mean? Grains, right? Different shades quite often means different grains, and the different shade means, okay, it's one grain versus another grain. Quite often they would reflect the light in slightly different fashion. You would see them quite often. Okay, and then people put so-called AR coating that gives you that blue color, and then put the silver on top of it, the grid on top of it, you get silicon solar cell. But fundamentally, you can use solidification, going from liquid to solid, to get semiconductor or get commonly metals. Make sense? So they are very, very important for structural material as well as for so-called functional semiconductor material. Or these are single crystal sapphires, which is single phase, single crystal aluminum oxide. You can get typical aluminum oxide, that white ceramic wire, but when you do this carefully, when you pull a seed from a liquid aluminum oxide melt, you can grow carefully these types of high quality, extremely high quality single crystal transparent sapphire, which people can use for display or for optical purpose. And I believe the Apple Watch, probably that front piece of transparent, you call it glass, it's sapphire. But for iPhone, it's not yet. Why? Because it's much more expensive to grow a larger piece, right? To control the quality over large areas, much more expensive. But for smaller Apple Watch, you can do it. Make sense? Okay, and the topics that we are going to cover would include so-called driving force and barrier. Driving force means, okay, what provides the energy for this process going from solidification, liquid to solid? Okay, what drives it? And what would be the barrier? What would be the barrier in this process? Believe it or not, there will be barrier even below the melting point. There will be barrier. We will talk about it. Okay, and what is the so-called critical condition? Critical condition. Under what condition can we start to get so-called single crystal? Under what condition we start to get polycrystalline material? Okay, and then what about the rate? Remember, this class is about phase transformation and kinetics. Kinetics means how fast something happens. That is rate aspect. Okay, how do we understand the rate? And what will be the impacts of different parameters? For example, composition. How does composition impact the rate? How does the processing condition, temperature, pressure impact the process? How would the presence of interface or impurities influence? These are the things that we will talk about. For some part in detail, some part we just quickly go